Hello everybody, we are going to finish our 6.6 notes today. Last part of 6.6 notes, we talked about solving exponential equations. So now we're going to talk about solving logarithmic or natural log equations. If our equations already have log or natural log in them, can we still add log or natural log to solve? And the answer is no. We have to do opposite operations. So the opposite of having a log or a natural log is to rewrite it into exponential form. But there are a few other ways that we can do this as well. The biggest thing to make sure that you remember for this section is to make sure that you talk about checking for extraneous solutions. What are extraneous solutions? Well, that means we did the math correctly, but when we plug the answer back into our original problem, okay, the original, then the answer doesn't work. When would this happen with a log or a natural log? Well, go ahead in your calculator and find the answer to these three log problems. What did we get for all three of those? We got error or no real solution or something like that. So what can't happen? We cannot take the log or natural log of a negative number. It's not possible. Three types of situation we'll look at for solving logarithms and natural logarithms. So if we have the exact same log with the exact same base on either side, it's kind of like the like bases that we did with our exponential functions. When this happens, then we can say 4x minus 7 is equal to x plus 5 and solve for x. We'll subtract x from either side. I'm going to add 7. So we have 3x is equal to 12. And then divide by 3, and we get x is equal to 4. Now remember, we have to check for extraneous solutions. So I have to take that 4 and plug that back into each one of these and make sure that I'm not ending up with a log of a negative number. So if I plug 4 in here, we have 4 times 4, which is 16, minus 7 is 9. And then over here on the right, if I plug in 4, 4 plus 5 is 9. So we have log base 5 of 9 equals log base 5 of 9, and we're good to go. So x equals 4 is a good answer. Over here on our next example, again, they're both natural log, which are both base e. So we have 7x minus 4 is equal to 2x plus 11. Subtract the 2x. Add the 4. We have 5x is equal to 15. Divide both sides by 5, and we have x is equal to 3. Again, we have to make sure we plug that back into the original equation to see, is that a good answer or is it extraneous? So 7 times 3 is 21. 21 minus 4 is 17. So we have the natural log of 17. On the right side, 2 times 3 is 6. 6 plus 11 is 17. So those are both positive answers, and we have the natural log of 17 is equal to the natural log of 17. Situation 2. There's only one log in the equation. We use our circle of logs or left, right, center to rewrite it in exponential form to solve. So I'm looking over here at our bases 4. So we have 4 to the third power is equal to 5x minus 11. 4 to the third power is 64. Add 11 to its like term of 64. We have 75 is equal to 5x. Divide by 5, and x is 15. Make sure we do our check. Log base 4 of 5 times 15 minus 11 equals 3. 5 times 15 is 75. 75 minus 11 is 64. 64 is a positive number, so I'm good. And if I either do change of base formula for log base 4 of 64 to see if it equals 3, or if I rewrite it 4 to the third power of 64 and see if that's true, either way, we're good to go there. All right, the second one, rewriting it in log form, we have 2 to the 5th is equal to x minus 6. 2 to the 5th is 32. Add 6, and we have x is 38. Do our check. We have log base 2 of 38 minus 6 is equal to 5. 38 minus 6 is 32. 32 is a positive number, so that part's good. And then you can either use change of base formula to get log base 2 of 32 into your calculator and check that it equals 5. Or you can try 2 to the 5th power to see that it equals 32. Either way, we're going to find that's a good answer. Last but not least, what if we have two logs on the same side? So they're not on opposite sides like our first situation. They're on the same side. So we're going to use our log properties, and we're going to go backwards to condense from 2 logs to a single log. Then rewrite it as an exponential equation, like we did in situation 2. And most likely for these, we will get to factor. We know that you missed that, so let's bring factoring back. All right, we have log base 10 and log base 10. Remember, adding started when we talk about our log properties. That started as a multiplication problem. So when we want to condense this back, we have log 2x times x minus 5 is equal to 2. I'm going to distribute that 2x to get rid of those parentheses. We have 2x squared minus 10x is equal to 2. Now remember, this is a base 10, so we rewrite it in exponential form. That gives us 10 squared is 2x squared minus 10x. 10 squared is 100. And then in order to solve for x, we have to get this set equal to 0. So we need to bring that 100 over to the right. Now we get to factor. Remember, for factoring, we always start with pulling out a greatest common factor if we can. 2, 10, and 100 have a common factor of 2. That's going to leave us with x squared minus 5x minus 50. So the factors of negative 50 that add to negative 5 are going to be negative 10 and positive 5. Change colors so we can see. So we have x minus 10 and x plus 5, along with our 2, is equal to 0. Now remember, for solving, we take anything that has an x and set it equal to 0. X minus 10 is equal to 0, so x is equal to positive 10, and x plus 5 is equal to 0, so x is equal to negative 5. Now remember, we can't say that those are our answers yet because we need to check our original equation and see if those answers work out to be good answers. So I'm going to start with the positive 10. We have log of 2 times 10 plus log of 10 minus 5 is equal to 2. And remember, our first concern is that I don't end up with a log of a negative number. So that's log of 20 plus log of 5 is equal to 2. We can plug those into our calculator and see if log 20 plus log 5 indeed is equal to 2. And we've also checked that 20 and 5 are positive numbers. So it looks like 10 is going to work out. Then we need to check our negative 5. So log of 2 times negative 5 plus log of negative 5 minus 5 is equal to 2. Well, 2 times negative 5 is negative 10, and negative 5 minus 5 is another negative 10. Well, right here, because of these negative 10s, I can't go any further. We cannot take the log of a negative value. So 5 is extraneous, and our only answer is positive 10. Our second example. Again, we have log base 4 plus log base 4. They're on the same side, so we need to condense them together to 1. This adding started as multiplication. So we have log base 4 of x plus 12 times x is equal to 3. I'm going to distribute the x squared plus 12x. Now that we have a single log, we rewrite it using our circle of logs or left, right, center. So we have 4 to the third power is equal to x squared plus 12x. 4 to the third is 64. And then remember, because we know we want to factor and solve, we need it to be equal to 0. So I'm going to again subtract the 64 over to the right side. So I'm equal to 0 on the left, and I can factor on the right. Take out a greatest common factor if we can. We cannot because in front of the x squared is a 1. So we need the factors of negative 64 that add to a positive 12. And that's going to be a positive 16 and a negative 4. So we have x plus 16 times x minus 4 is equal to 0. That gives us x is equal to negative 16 and x is equal to positive 4. Now for our check. Start with that negative 16. Log base 4 of negative 16 plus 12 plus log base 4 of negative 16 is equal to 3. Well, negative 16 plus 12 is negative 4, and then we have negative 16 here. So because of these two negatives, 16 is extraneous and is not possible. Be careful though. We cannot automatically say that that means the positive 4 will work. Sometimes both of them can be extraneous and we don't have an answer to this problem. So I'm going to now check that positive 4 to make sure that it'll be an okay answer. So we have log base 4 of 4 plus 12 plus log base 4 of 4 is equal to 3. 4 plus 12 is 16. And then we would again check in our calculator. Log base 4 of 16 is 2. Log base 4 of 4 is 1. Does 2 plus 1 equal 3? Yes. And these two values are positive. So we could get them into our calculator, and x equals 4 is a good answer. All right, ladies and gentlemen, that's it for today. Have a great one.